Hey, welcome back, you guys. Today we're going to take a look at Chapter 7, Lesson 3. It's similar in congruent figures. So the first thing I'd like to do is just kind of remind you guys what congruent is. And that's two shapes that are the exact same size and shape. Maybe they have been reflected, maybe they've been translated, rotated, or dilated. So let's go ahead and take a look at the first one right here. And we're going to identify if this is congruent and if it's similar. So are these two shapes the exact same size and shape? Yes, they are. So they're congruent. Okay. Now, similar means the exact same shape, but possibly a different size. So these two here are the exact same shape. So they are congruent and they are also similar. So let's come on over to the one off to the side right here and we'll take a look at that. So let's check to see if they are congruent first. That means the exact same shape and size. They're different, so they're not congruent. Let's see if they're similar. Are they the same shape? They're both rectangles, but they're not the same shape. So they are not similar. All right, coming down to the bottom one here on the right, are they congruent? Nope, they're not the exact same size and shape. And for similar, we're just going to check to see if they're the same shape. And they are not the same shape. All right, let's go ahead and move to the next one here, the exact same size. They're not the exact same size, so we're going to say no. But are they similar? Yes, they are similar. Now, there's a way that I want you guys to check to see if something is similar. If you're not 100% sure, what you would do is you would check maybe the length of this side right here, and the length of that side is 1 unit, and the length from here to there is 1, 2, 3 units. So there's a scale factor of 3. And that would mean that this side here would have to be 3 times this side right here. Okay? And this side is 2 and this side is 6. So we would say yes, so it is similar. Okay? Let's move on down to the next problem here, you guys. So next problem here, the effect of dilation on side length. And we're going to take a look to see what we're supposed to do here by reading this. For the figure, do a dilation centered at the origin with a scale factor of 3, and then answer each part. Okay, I'm not going to be able to slide the slider on mine here, you guys, because I'm actually writing over the top of this. But we're going to slide this so we have a scale factor of 3. And when you do so, it's going to multiply each side length by 3. So I want you guys to do that first, and then I believe you're going to have a new image that's going to appear, in this general area right there. It's just going to be 3 times the size of that one. Okay, so let's answer some questions here. The longest side of the original figure, so the longest side of the original figure is 1, 2, let's go 1, 2, 3. So 3 units. And the largest side of the final figure, if we take the 3 units and we multiply by a scale factor of 3, that's going to give us a 9. Okay, fill in the blanks here for the next one. The longest side of the final figure is equal to what times the longest side of the original figure? So it's going to be a scale factor of 3, so it's going to be 3 times the longest side of the original figure. All right, looking at the next one down here, you guys, true or false, a dilation with a positive scale factor greater than 1 gives a final figure larger than the original figure. So think about that for a second, you guys. If you multiplied something, maybe it's your age, and if you multiplied your age by 1, it's not going to change. It doesn't make it any larger. But let's say if we multiply your age by a number that's greater than 1, so maybe we did 2, or maybe even just 1.1. It's going to get larger, right? So we could say that this is true. And for the last part, true or false, the original figure and the final figure are similar. Yes, it's going to be the exact same shape. They're just going to have different sizes. All right, there we go. So let's move on down to the next one. So determining if figures are related by dilation. So we are asked, in each part, dilate this solid figure exactly onto the dashed figure. If this is not possible, then click not possible. So what we're going to try to do here, you guys, is we're going to take this slider and we're going to move this slider to the right or possibly to the left sometimes. And we're going to see if we can turn this figure here, the solid figure, into the dashed figure up there. Now I can tell by looking at this that this one up here is a square, and this one down here is a rectangle. So there's no way I'm going to be able to turn a rectangle into a square just by making it larger or smaller. So this one here, we would definitely want to say that this is not possible. Now let's take a look at the next one here. We're going to go ahead and do the same thing, move the slider to the right or the left. In this case it's going to be right, and we're going to see if we could turn this figure into that figure there. Now there is a way to check this just with a little bit of math. I could check and see that this side from here to here is 1, and let's see, this side here is a 2. So on the sides there's a scale factor of 2, right? Going from the small one to the large one, it's 2 times that. So if it's going to be similar, we would have the same scale factor for this side down here. Whoops. So this happens to be 1, 2, 3. So this is a 3. And if we were to multiply 3 times 2, we'd get a 6. And we would want to make sure that from here to here is 6, and it is. All right, you guys, so that's going to be it for chapter 7-3. If you guys have any questions, make sure you check in with me. And aside from that, I'm just going to say good luck on your homework, okay? So this one is possible. We can do it. All right, I think we got one more, and then we're going to be done, you guys, all right? Okay, the last one here, you guys, is determining if figures are similar and related by a sequence of transformations. So let's see what we got here. Answer the question about figure A and figure B. So we're looking at that information that's right there.